Hello friends, welcome to this video on quadrilaterals. So far, we studied some properties of triangles and quadrilaterals. Today we will study another property of triangles, that is the midpoint theorem. Friends, draw a triangle PQR, the lengths of whose sides PQ, PR and QR are 5 cm, 6 cm and 7 cm respectively. Now, suppose the midpoint of side PQ is M and the midpoint of QR is N. That is, PM is equal to QM and QN is equal to RN. And draw a line segment MN by joining the points M and N. Can you now tell any relation between the line segment MN and the side PR? Let's see. With the help of a scale, find the length of the line segment MN. Friends, you can see that the length of the line segment MN is 3 cm, which is half the length of the side PR. That is, we can write it in this way. Can you tell any other relationship by looking at the figure? Looking at it, both these lines seem to be parallel. We can test this. Let us find the measurement of the angles, that is, angle QMN and angle MPR with the help of a protractor. The measurement of these two angles is equal. Why did we only find the measurements of angle QMN and angle MPR? You can also pause the video to think of the answer. Friends, we know that these two angles are corresponding angles formed by the intersection of the line segments MN and PR with the transversal PQ. If we use the converse of the corresponding angles axiom here, then we can say that the line segment MN and side PR are parallel. Friends, you can repeat this activity by taking some more triangles. Now, you will reach to the conclusion that the line segment joining the midpoints of any two sides of a triangle is parallel to the third side. This is what we call the midpoint theorem. We can prove this mathematically as well. Let's see how. Now, we draw a figure with the help of the statement. In triangle ABC, the midpoints of the sides AB and AC are P and Q respectively. This is given to us. And we have to prove that the line segment PQ is parallel to the side BC. Let's see the proof. We have to make a construction here. Extend the line PQ to the point R in such a way that PQ equals QR. In this way, we can join R and C. Here, we get two triangles, triangle AQP and triangle CQR. In this, the side PQ is equal to the side QR, and we are given that point Q is the midpoint of the side AC. Therefore, the sides AQ and CQ will be equal. Angle AQP and angle CQR will be equal because these are vertically opposite angles. By looking at equations 1, 2 and 3, we can say that these two triangles are congruent according to the SAS criteria for the congruency of triangles. And we know that corresponding measures of congruent triangles are equal. Hence, angle PAQ and angle RCQ will be equal. And these two sides will also be equal. Friends, these two angles are alternate angles, which are formed by the intersection of the sides BA and CR with the transversal AC. And we know that if a transversal intersects two lines in such a way that a pair of corresponding angles is equal, then both the lines are parallel to each other. Hence, the side BA will be parallel to the side CR. As we can see in the figure, points B, P and A are linear, or we can say that they are on the same line. Therefore, we can say that the side PB will also be parallel to the side CR. And we are given that side AP is equal to the side PB and side AP is also equal to the side CR. Hence, the sides PB and CR will also be equal. Friends, look at the quadrilateral PBCR. It has a pair of opposite sides, parallel and equal. And we have learned that a quadrilateral is a parallelogram if a pair of its opposite sides is equal and parallel. Therefore, using this theorem, we can say that it is a parallelogram. Hence, the sides PR and BC will be parallel and equal. Here, points P, Q and R are linear, that is, on the same line. Hence, the line segment PQ and the side BC will also be parallel. In this way, we prove the midpoint theorem. Friends, we got to know that PQ and QR are equal. Hence, we can write it like this, and from equation 6, PR and BC are also equal. Here, if we write BC in the place of PR, we get the side PQ as half of the side BC. Friends, the point to note here is that the length of the line segment formed by joining the midpoints of the two sides is always half the length of the third side. Will the converse of this theorem also be true? Does a line drawn from the midpoint of one side of a triangle parallel to the other side bisect the third side? Friends, you can perform an activity for this. In triangle XYZ, side YZ is 8 cm, side XZ is 6 cm, and the side XY is 5 cm. Point T is the midpoint of the side YZ. Line segment TS is parallel to the side XY. So, will the point S in here be the midpoint of the side XZ? With the help of scale, try to find it yourself. And you will see that point S is the midpoint of the side XZ. And here also, the length of the line segment TS is half the length of the side XY. You can repeat this activity for other triangles as well. Now, you will come to the conclusion that the converse of the theorem is also true. That is, a line drawn from the midpoint of one side of a triangle parallel to the other side bisects the third side. Try to prove it with the help of friends and teachers. Friends, that's all in today's session. Today we discussed and proved the midpoint theorem. See you in the next video with some questions based on this. Thank you.